Hey everyone, this is Dr. Walker. In this video 507, we are going to introduce vector notation for Coulomb's law. Up to now, when we've used Coulomb's law, we have used it to find the magnitude of the force between two charges. So here is Coulomb's law in vector notation. In this case, it's giving us force 1, 2, which is the force from Q1 acting on Q2. So it's this force over here on the right. We are completely ignoring the force on the left over here. So the force is given by Coulomb's constant times the product of the two charges divided by the distance squared between them. And then the purpose of the vector notation is that we have a direction for this force, which is specified with the unit vector r hat. So r hat is a unit vector, in this case directed from Q1 towards Q2. In case you don't remember about unit vectors, they are dimensionless vectors used to specify direction. So they don't have, their dimension is 1, they don't have units, they're just used to specify the direction, in this case away from Q1 towards Q2, which is the force that we are interested about. So what's noteworthy about this notation is you are going to put in negative signs for the charges as necessary. If your charges have like signs, then the product will be positive, and that means that the force on charge 2 will have the same direction as the unit vector towards charge 2. As you can see here, the force and the unit vector have the same direction. And this makes sense because positive charges repel. We expect the force to be pointing towards the right. If we have unlike charges, then one of them is positive, one of them is negative, this product will be negative. And that means that the F12 is going to equal the negative for the direction. It's going to equal negative r hat direction. So F12 is going to be in the opposite direction as r hat. This is what we expect since the two charges will attract each other. So r hat hasn't changed. R hat is always the vector away from Q1 towards Q2, but the force in this case is in the opposite direction when we have unlike charges. We can use the superposition principle for Coulomb's law. It is written this way. So in this case, this signifies the force acting on big charge Q due to a bunch of other charges. So let's say we have a charge Q over here, and we have a charge Q1 and a charge Q2 and a charge Q3, etc. Let's say we have a bunch of charges that are exerting forces on charge Q. Then this is how we would sum up the contribution of each charge. The summation from 1 to n, where n is the number of individual charges. And we do the individual charges divided by the distance between those charges and Q. And we have the unit vector direction. So using the superposition principle definitely requires vector addition, since we cannot just add them like scalars. I just like to think of the superposition principle as adding all the contributions from each charge. So in this case, if I call this Q4 and I'm looking for the force on charge number 4, then I would just say it's force 1,4 plus force 2,4 plus force 3,4, where I am adding all of these vectors and paying attention to direction. So that's it for this video. We are going to have a couple of examples where we can practice using this vector notation.